Hello, good morning, all dear my kids. One more time, welcome again, welcome again. I think the screen is not aligned properly. I hope it is fine now. So, again, welcome back to the next part of physics and another fine day to start with. I hope all of you understood. It's not about understanding. At least all of you seen that video one or two times. Okay, understanding it's in the next level because the everything is linked between each other in physics. That's it. The entire part of classical mechanics is linked between each other, and in and standard you are studying it. That's a fact. Anyway, that's a fact. We cannot change it. We must study that. Lots of numericals will come from these parts of the textbooks and also from the notes which I am giving. Mostly I will try to provide all these notes or based on previous year questions and answers. So next one is about what? Yesterday we studied about floating points. Am I right or not? X-axis, what we will take in x-axis? Of course independent variables, and in y-axis we will take dependent variables. For example, if it is velocity, in which axis we will take? Y-axis. Displacement, which axis we will take? Y-axis. Speed, which axis we will take? Y-axis. Time, which axis we will take? Yes, it is x-axis. Let's go. So these are the four different types of graphs in this chapter. Distance and time graph. Values will be given as distance and time. Displacement, time graphs. Values will be given as displacement and time. Velocity, time graph. Values will be given as the velocity and time. Acceleration, time graph. Values will be given as different types of acceleration and time. The main thing is this one, okay? Independent variable is taken along x-axis. Whenever you are drawing a graph, time comes where? X-axis. All the other values comes on y-axis. Only regarding this chapter, okay? In other chapters, different independent variables are there. In this chapter, times come in x-axis. So the first is distance time graph. So you know what is distance, isn't it? Okay, let's see. So distance time, from distance and time we can find something. What is it? Tell me. Distance traveled by time taken is what? Of course it is speed, isn't it? Am I right or not? Yes, distance traveled by time taken is the speed of a particular body. So this graph is used for what? For finding out the speed of that particular object. For example, in this graph we are plotting distance against time. Distance is 4 meter, time is 3 seconds, and we got this point as the speed. What is the speed during this point? This divided by this, right or not? 4 divided by 3 will get what? 4 by 3, isn't it? Yes, like that we want 1.25 also is the correct answer. Let's see here. The change in position of a body with time can be represented on the distance time graph. So what are the main things we are representing on a distance time graph? The change in position of a body within time. Okay, for different times, if we are observing an object. For example, if you are observing what? The position of the sun. Each time it is moving. Am I right or not? And your observation, you are marking it in your paper. Morning 6 o'clock, the sun is in this position. 7 o'clock, another position. 8 o'clock, another position. All those things, all those readings, we can mark it in this graph. Okay? And from that you can find the speed of the sun. Is it amazing? Let's see. Okay. In this graph, distance is taken on y-axis and time is taken on the x-axis. Okay, no problem. Anyway, every time it is taken as in x-axis. The distance time graph for uniform speed is a straight line. Uniform speed we will discuss in the next picture. See, this is a distance time tracked when the unit is at rest. Okay, unit is at rest. What may mean by that? For example, a unit is 2 meters away from us. This is the point where we are standing, and this is the position of a particular object. It is like 2 meters. Just imagine it is 2 meters. That is constant because that particular object is at rest. Am I right or not? So the time is varying. Am I right or not? So in 1 second there is no change in distance. 2 seconds there is no change in distance because the particular object is at a rest. So how much time it is taken? If you take 20 seconds, 30 seconds, 40 seconds, 60 seconds, the position of that object is not changing, okay, because it is at rest. That type of graph, if we draw in a particular paper, we will get a parallel line to the x-axis. It's very simple, isn't it? Whenever we draw a distance time graph of a body which is at rest, we will get what? We will get parallel line with the x-axis. Next we can go. Okay. The distance time graph for uniform speed is a straight line. What is that uniform speed? Let's see. When the body is moving with uniform speed, that means uniformly it is moving, but it is moving, it is not at rest. Okay, for example, the speed of the body is 5 meters per second. 5 meters per second. What will happen? Okay, or 1 meter per second. Just imagine here, the time we are taking is 0, 1, 2, 3, 4, 5. Here we are taking 0, 1, 2, 3, 4, 5 meters. So if we plot a graph, I will get after 1 second it is moving 1 meter. The point will be here. 2 seconds, 2 meter. Here. 3 seconds, 3 meter. Only if it is moving in uniform speed, okay, then we will get a straight line. Understand? Which cuts this x and y in the center. Understood? Understand? See, when a body is moving with uniform speed, when the body is moving with uniform speed, the graph is a straight line, making an angle with the time axis, and the slope of this graph is given by the slope y1 divided by x2 x1, which is equal to speed. This we will discuss afterwards when we are solving the equation. Understand? Here it is not mentioned what is y1 and y2, x2 and x1. Actually it is the change in the distance. Okay, here it is not shown. Okay, that is the which is equal to the equation of the speed. That we will discuss in the time where we are creating equation. Just this thing you keep in mind. Distance time graph for a body at rest will be straight line which is parallel to the x-axis, and when the speed is uniform and it is moving, but the speed is uniform, it will be a straight line which cuts the entire plane into half. Okay, let's see. When a body is moving with non-uniform speed, what will happen? That means sometimes the speed is increasing, sometimes the speed is decreasing. What will happen? But here in this case, one difference is there. See, the body covers unequal distance in equal interval of time. That means the speed is not uniform. Slowly its speed is decreasing. Then the graph will be like this. Or if the speed is increasing, the graph will be like this. This is called as parabola. Okay, it's just an arc, like a curve, isn't it? But in physics it is called as, or in mathematics it is called as a parabola. Okay, parabola, just study that. So greater the angle, greater is the slope and greater is the speed. So in this case, just see. angle means which one? Angle which this x and y axis is making with that center line. So if the speed is decreasing, if the speed is decreasing in the distance times graphs, we can see that it will be a parabola which bend towards the x-axis. See, it is bending towards the x. Am I right or not? But if the speed is increasing, it is bending away from the x-axis. Okay, these are 4 cases of distance time graph. Understand? It's not that much difficult. You must understand that in your mind. Okay, distance time graph. Mostly we are taking 3 types of distance time graph. One more time I will just explain. The change in position of a body with time can be represented on the distance time graph. At first case there was no change. Okay, the body was at rest. Only time is changing. Understood? The body is this much meters away from us, but it is at rest. It is not moving. So only time is changing. That's why it's a straight line, which is parallel to the x-axis. Understood? But in the second case, how is going on? It is it's a uniform speed. It is moving with uniform speed. Speed is not affecting. Okay, it is uniform. For example, it is moving at 10 meter per second. 10 meter per second or 1 meter per second. See, it will be a straight line. Understood? And if it will be like 2 meter per second, how it will go? This angle will reduce. It will come in center. Am I right or not? 2 time is like no. This angle will reduce. This angle. Okay, that we will discuss in velocity. In velocity time graph we will discuss. So these are the 4 conditions. See the first graph. When the body is at rest, the distance time graph will be a straight line which is parallel to the x-axis. Next one, if the body is moving with uniform speed, the distance time graph will be a straight line. And when the body is moving with non-uniform speed, distance time graph will be a parabola. 2 cases are there. One, increasing the speed, decreasing the speed. Okay, non-uniform speed means if a body is moving with non-uniform speed means 2 cases are there. One, it can increase its speed. The other one, it can decrease its speed. In both cases, what we can say? We can draw a graph. If it is decreasing the speed, we will get a parabola like this. If you are decreasing the speed, we will get if you are increasing the speed, we will get a parabola like this, which is bending away from the x-axis, and in this case decreasing speed means bending towards the x-axis. Okay, so I think you need more explanation for this. Am I right? Okay, we will conduct one more class after finishing this chapter regarding this graph. I will draw it in board and show. Showing in board is more difficult. I think this is more easier for you. Am I right or not? This understandable or not? Uniform motion, uniform speed, or at rest? At rest, parallel. Uniform speed, it will be straight line. Okay. One more condition is there. Non-uniform speed. Non-uniform speed may be 2. Negative acceleration or negative speed. That means speed will be decreased, or speed can be increased. So at that time, we will write, or you will draw 2 types of map. One is decreasing speed distance time map and increasing speed distance time map. In one, not map, graph, sorry. In one case, it is bending towards x-axis when the speed is decreasing. In the other case, it is bending away from the x-axis. Okay. Okay, the next class we will go with displacement time graph. I'm not wasting your time more. I know this is a bit head eater. Am I right? No, brain eater. It's a brain eater. Okay, I know this is a difficult chapter. The next chapter is coming, my kids. That is about laws of motion and all, forces of nature and all. That will be double mind eater. Okay, these are the things. Just remember those names and all. This parabola is a 1 mark question, and this graph mostly comes as 4 marks, 3 marks, and that derivation of equations is an essay. derivation of equation detailedly we will study. It will take at least 6 or 7 classes more to finish this chapter. It's not a big chapter but a difficult chapter for you, because it's a new concept for you. It is very difficult for you to understand it the first time. Okay, my dear kids. So do the homeworks and all. That notes which I am providing, go through it. That's easier. Okay, that note is very easier than the test book. So till then, it's Mithun Raj signing from this part of the world. My dear kids, stay home, stay safe. Okay, hope all are doing well. All are praying for the school to reopen. Not only you students, we, the management, everybody is praying for that. Because almost 2 months of an academic year already went past. So we need to cope up with all those limitations during this time. Anyway, best of luck and all the best. Be safe, be healthy, stay at home, eat good food, be healthy. And this is Mithun Raj signing from this part of the world. Okay, my dear kids, see you with the next video. Till then, goodbye and Jai Hind.